Welcome, everyone. We're going to just wait a minute or two as folks join to the EMIS crash course. Hello, this is Hannah Kramer with Lawrence Berkeley National Lab, and we're going to get started here with our webinar today. It's a EMIS crash course, an overview of energy management information systems, and this is like a 101 type course where we're going to go through the nuts and bolts of what EMIS are and how to use them and how to get value out of them. Next slide, please. So thanks again for joining us. I am the EMIS tech team lead for Better Buildings, and I'd like to acknowledge the work of the group here. This is the entire group that does a variety of commercial building controls and analytics research and technical support. Elliot Crow will be managing the Q&A section. So be sure to put in the chat all your questions as we go forward, and he'll be organizing those, and we'll get to as many as we can at the end. So get your questions in early, and we will get to as many as possible. Next slide, please. So we're going to spend most of our time today going through the different EMIS capabilities with a whole load of examples. We want to get you a sense of what are the current capabilities out there without having to do demos of 20 tools on your own, and have you be able to think about what makes the most sense for your organization. There's no one size fits all solution, and really speccing out what are the needs that you have, what are the data and analytics needs, what are the data streams you have, and how do you want to use them. So we'll go through the capabilities, and then we'll come up with, we'll come to best practices, and the research results are really going to inform the business case. So we just finished a 4-year research program where we collected data on cost and savings. We have the biggest set of data in the country, and I'm going to be sharing an overview of the results of that. Hopefully that will help you make your own business case. And then a summary of resources. LBNL has been doing this kind of work for a long time, and we have amassed a load of resources that we want to make it real easy for everyone to access. Next slide, please. So I'm going to give credit here to Carleton College. They were one of our campaign participants in the Smart Energy Analytics campaign, and they put together this slide, and I just kind of feel like a picture's worth 1,000 words. When people look at this slide, they start nodding and saying, yeah, I have lots of Excel spreadsheets. I have a lot of data that doesn't get updated automatically, and I have to do all these manual process, and it's not real time. So this is what people start with. This is where most people are at before they have an EMIS, at least from this is an example of energy information and some system information prior to having EMIS. Next slide. So this is where Carleton got to when they implemented their energy information system. They were able to have all their meters cataloged in nice order, know which meters went to which areas, and be able to benchmark their buildings across their campus, look at 15-minute interval data for any building, and really flag anomalies. So they went from a big mess to something that they could actually use, and their energy manager used it as a basis for weekly meetings. Next slide, please. So we're going to come back to this repeatedly throughout this presentation, where this is kind of an overview slide on the umbrella term for energy management and information systems, encompasses all these different capabilities. And some EMIS tools focus on a certain set of capabilities, but more and more the tools are encompassing multiple capabilities and able to do, let's say, have energy information system and fault detection and diagnostic capabilities in one tool. So that's been a big change over the years. You know, just the flow of this data, you're all aware of all these different data sources and trying to manage all those different data sources. You know, there's utility bills, the interval meters, whether you have data from your utility, smart meters, or just sub-meters on site, weather data, building automation system data, and now IoT devices are giving us more access to data more easily. And even down to, you know, data about how your PV system and your batteries are working, eventually, potentially even microgrids. So data sources abound. Having a data warehouse to keep organized with all that is really important. And then applications that sit on that data warehouse and have these capabilities to really help you use the data in ways that are actionable rather than just overwhelming. Next slide, please. So overlaying on this, I wanted to kind of show the arc of how this has changed over the years. I've been working in this field for over 20 years and things have changed a lot. So it's not your 20 years ago energy information system anymore. It's a lot better. And so if you haven't looked at them in a while, this will be a good chance to take another look. There's so many vendors out there that can be a great opportunity and also somewhat overwhelming. In the monthly data analytics, that's been around the longest. We've seen over 70 vendors with about 10 of them really focused on utility bill management and processing, you know, getting those utility bill data into the system, automatic payment, that kind of thing. Not all these EMIS do that. So that's sort of an area that's focused on the ones that really focus on monthly data analytics. Then you have energy information systems that take interval meter data, 15-minute to hourly data, and help you do meter level M&V. These have really expanded over the last 20 years into ones that, and we'll give lots of examples of what these look like and how they do their M&V. There's over 70 of those. In fault detection diagnostics, you know, when I first started out, there was a handful. Now there's over 40 tools that have that capability. And fault detection and diagnostics in a nutshell is, you know, using the building automation system data and giving specific faults based on models or expert rules. And then finally, automated system optimization. This is newer. We're going to talk about the differences between FDD and ASO in a minute. There's fewer products, but there is a lot of opportunity to automate some of the controls fixes coming out of this FDD process. So we'll get to that as we go through this list of capabilities. Next slide, please. All right, so EMIS tools in action. You may have heard of the term monitoring-based commissioning. And really, the point of this is that EMIS, themselves don't generate savings, it's how they're used. So you need a process to get that use out of them. Although we will talk about ASO later, in that there is automation of portions of it through ASO. But in general, we need to have a human in the loop and a process to review what's coming out of these tools. So we collect data in the data warehouse, we get it organized, that's all automated. The data analytics give you actionable information to your engineer. And then outside this box, you have a building engineer who reviews the analytics, makes repairs or improvements. Sometimes the analytics is connected up to a work order management system, sometimes it's not. and then using the EMIS to monitor and track improvements and measure savings going forward. So you're really closing that loop. And instead of just fixing something and hoping it was fixed, you can actually verify that it was fixed. So monitoring-based commissioning is a kind of a term that's used to look at a comprehensive energy management program that's continuously looking at the data using an EMIS. But really any energy management program can use an EMIS. It doesn't have to be as comprehensive as MBCX. All right, so we're gonna start off, next slide, with monthly data analytics. This is sort of like the bread and butter of making sure you're on top of your utility bills. And a lot of folks already do this. Sometimes it's more cumbersome when you don't have good streamlined process to get the bills into the system. But in general, this is pretty well understood in the industry that you're doing energy use and cost tracking, and starting off with benchmarking against your portfolio is really the best place to start. In your energy use intensity, if you have a portfolio of buildings, focusing on ones with a high EY. And more and more of these monthly data analytics tools automatically link to Energy Star Portfolio Manager. So you're probably familiar with, an Energy Star score, trying to get a 75 to get an award or more. And rather than, having two different tools, these tools can automatically share the data, the monthly data, utility data that's needed for Energy Star, and generate a score and bring that score back into the tool so you can track it. That's a pretty nice feature. And then they also can be used for utility bill checking for errors and that kind of thing. Okay, a couple examples of these. Next slide, please. I mentioned the EUI, you up in the top left corner, you can look at energy use intensity per month, and the line on the top is the overall annual EUI changes. So you're kind of seeing a rolling 12-month average of how the EUI is changing. It's just, these are big picture indicators. You have your energy cost and your internal benchmarking in the purple bars here, so you can know where to focus your efforts. Next slide, please. Taking monthly data analytics just a little bit farther, there's modeling of a baseline period and then projecting that baseline into the current period. So you're basically normalizing for weather with monthly data. This is one example in the top left corner here. This helps you take weather out of the equation, and in this chart in particular, you have a Q sum, which you may have heard of, a cumulative sum of savings. So you can see as that line goes up, that means your overall savings cumulatively are going up. As that line goes down, that means your savings are eroding. So in a big picture, you can look at Q sum as a way to look at a meter level, what's going on with your building. On the right side here, we have Energy Star Portfolio Manager. You can track your score over time. All right, next slide. We're going to go through, for each of these categories, we're going to have examples of vendors that provide that capability. That may not be the only capability they provide. These are also not a comprehensive list. They're not, it does not mean endorsement if we have them on this list, or it doesn't mean that we're not endorsing them if we don't have them on this list. So I give you those caveats. DOE does not promote any particular tools. We're really promoting the active use of these types of tools. So this is your, like I said, your bread and butter, benchmarking energy goals and tracking progress. Almost 10 years ago now, EPA did a study of 35,000 buildings, and with benchmarking, they're able to save 2.4%. That's just basically like, looking at the data and knowing what you're using can lead to savings. All right, next slide. We're going to move on to energy information systems. And this is where we get into a lot more detail on interval metered energy data. There's always a question of, You know, can I just look at whole building interval meters, or do I also need sub-meters on everything? Most people who have EIS have end use, so they have fuel-based meters. So they have electric, they have gas, or if they have steam or hot water. So they know at the big picture, they can track their energy by building. So for sub-metering, sometimes campuses don't have those meters per building, so they're going to put sub-meters on each building. But in general, you can get away with the whole building. And if you have particular systems like a data center that you want to sub-meter, that's great as well. These tools have historically given you data visualization capabilities, you know, with the interval meters and overlaying weather, normalizing for weather. And now more and more, they're bringing in more data sources, IoT sources that you may not already have accessible. You may want to do CO2 sensing or wireless sub-meters through an IoT device. And so that's becoming more and more prevalent. Okay, so we're going to look at some examples of how you would use these. Next slide, please. There are countless types of charts. There's a lot of flexibility in these tools in general, but at the core, we're looking at visualization and analytics using hourly data at the whole building level and sometimes sub-meters. With summary KPIs and indicators of savings opportunities. So here on the left, you'll see a heat map. Many of you use heat maps. This is one of the most beloved portions of an EIS. People really get a lot of value out of looking at the colors to denote the level of energy use. So it's just easy to see almost a full year of energy use throughout each hour of the day. And you can see if you have your schedules in line, you can see if you have some unexpected energy use in particular months or weeks. And this is a nice big picture way to say, okay, where am I starting from? In the middle, we have a load profile analysis. This is where you can see for a 24-hour period what your base load is, what your peak load is. In this particular situation on the top, they show a median, a min-max, and this is over, I think, a month period or so. This can be enlightening. You may not know that your building HVAC stays on 3 hours past what you thought, and this can give you like a little indicator of that in your load. The usage calendar is in some EIS. Those are interesting because you can see which days correspond to higher energy use days relative to a modeled prediction. So in this case, the red, that day was higher than others. You can start to see patterns like our Mondays worse, our weekends okay, that kind of thing. And then on the right, we have a real-time load shape. So you see in the green, the light green, we have a predicted band. That's based on a model of past performance. And we have the actual use in real time relative to the predicted band. This is a good way to just see real time if you're on track. And below that, we're going to expand in the next slide of the ways that you can do analytics on that piece. Next slide, please. So relative to the prediction, this is a summary of when the energy use was outside of prediction. There's these improvement opportunities around early startup, excess weekend operations, demand spikes, and things that you can see in your load shape. So this is an example from one of our partners that shows which days there were which problems, how just sort of a big picture of how often do these problems occur. I think these visuals really help you get a sense of what the opportunities are without having to do a lot of analysis. It's just sort of already here for you. So it also gives you an estimated savings compared to if you were to bring that back in line with the modeled performance, the intended performance, and you can track your performance with improvements going forward. So this is a nice way that energy information systems have taken it to the next step to not just display data, but give you actual analysis that you can act upon. Next slide, please. Forecasting. So this is where there's a lot of power in energy information systems. What we used to call advanced EIS is now common in most EIS. So basically what they do is they take a baseline period of interval meter data and make a model of the energy use. They project that model into the current period, and the actual energy use versus the projected baseline is your savings. So you can, let's say you could run a energy competition and create a baseline and then see what the savings are each hour of the day relative to that baseline. This, again, this is at the meter level. So there's always like questions about, are there other things going on? Are the savings really from X, Y, or Z? So you have to kind of say, well, in aggregate, the things we're doing are giving us savings that's weather normalized relative to this period as our baseline. And there's a whole lot of other information we have available on how to make good baselines and how to correct for non-routine adjustments, and we won't get into all that. But these tools have this all embedded, so you can very easily create these baselines, reset them when you need to, and so forth. You can also, and not just M&V, you can see when things are going out of whack. You can set your baseline to sort of a commissioned operation, and then when something goes, let's say 10% outside of the prediction, you can get a flag. All right, so next slide, just to summarize, we have energy information systems. Again, these are just some examples of the, when I say over 70, this is just a few. We're going to get into savings in a bit, where we saw 3% savings in our data set. We've talked about the benefits. Really, you know, without EIS, you're just waiting for utility bills, and they're way too late by the time you actually get that data and have access to it. So, you know, energy managers need this as a tool. We have this real-time data analytics, and energy managers do not need the hassle of Excel spreadsheets anymore. We have much better tools than that. All right, next slide. We are going to move on now to the third category of fault detection and diagnostics. You may have heard of FDD software that automatically identifies equipment faults and tells you what the potential causes of those faults are. The hidden energy waste in buildings is enormous. So even if, you know, a building has a new building automation system, there's always seems to be a lot of savings to be had, and it's not easy to find. Nobody has time. Your operators don't have time to just sit there and look at the trends, and generally building automation systems don't make it real easy to find this hidden energy waste. Some of them don't even like overlay multiple points for a long enough period of time to really do diagnostics within the BAS. So FDD helps out a lot. You can find problems before they become comfort complaints. And this is just here a list of systems generally that have FDD applied to them. And it goes down to the terminal unit and sensor level. So it can really help you with your maintenance programs instead of, you know, a preventive maintenance program that tries to touch every unit. You're going to go to the units that have faults detected. Next slide, please. So here we have an example of what we mean by fault detection. And we just want to kind of give one out of, you know, there's hundreds of these faults that are being analyzed all the time behind the scenes with FDD tools. So you have your real-time building automation system data and you map it to the fault detection diagnostic tool. That's an important process, but we won't get into the details on, but we have a lot of other webinars, on that. And there's static data and control parameters. So we know, you know, how big your system is, what your intended outside air is like, what's your economizer, sequences, and so forth. So it knows what your system is supposed to be doing. And then you're going to, the tool looks at, let's say in this case, it's looking at percent outside air and whether your economizer is working. You know, you want 100% outside air when it's the temperature's out where you want to use that air and so forth. And this example just shows like a red flat line as your data, your actual data. It's stuck at 20% outside air. And there, you know, this calculation of percent outside air is based on your mixed air temperature, outside air temperature, and return air temperature. So all this stuff is like things you don't want to have to calculate on your own. And then the diagnostics routine looks at, well, it could be a damper issue. It could be your sequence of operation was never programmed right to begin with, or is something's wrong, or a sensor is out of whack. It's going to tell you based on your data where it can, what the root cause. So in this case, maybe if it's flatlined at 20%, you should investigate the dampers and actuators to see if that outside air damper is working. So then you would fix issue, and verifying it with FDD just means that flag is no longer flagged because it's not detecting that problem anymore. Okay, so that is one example of many for fault detection. Next slide. We're going to look at here just what some of the screenshots look like. So in the upper left corner, this is a very common look of where you're looking at fault by fault by fault. The colored bars means the duration of the fault. This one is a SkySpark installation at LBNL. The middle one is digging, like clicking into a fault, then you would see information about the opportunity, exactly, you know, what the suggested actions are, maybe what other faults it relates to. So that's an example of kind of the diagnostics piece underneath. And then in the upper right, this is an example of where FDD tools are not just flagging faults, you can also create dashboards that help you look at your system in a way that helps you, you know, find out what's going wrong, or without looking fault by fault. So in this example, you're looking at your supply damper commands, and you can see which dampers are 100% open, which indicates a problem, which are going back and forth, and which are 100% closed. So this can easily say, oh, I need to go look at those air handlers and look at those VAV boxes and see what's going on there. All right, next slide, please. Now, one complaint with FDD is there's way too many faults that it finds. And so this current generation of FDD tools generally has a feature to help you prioritize that ranking of issues and rank them. So this is just one example of many of how tools can prioritize based on avoided energy costs. So there's a calculation done that uses the data related to that particular fault. And in this case, it's a cost per quarter. So if you don't correct it for 3 months, this is the cost waste for that particular fault. And then where it's harder to put dollars for energy savings on, but you know that there's maintenance impacts, there's equipment longevity, you're gonna have a severity priority, which is assigned by the tool as well. So this is one way to help prioritize where the list may start out to be 100, but you're really just focusing on the top 5 in each category. Next slide, please. Dashboards at the big level, or at the big picture level, are also really important for FDD. So prioritizing the faults, but then also being able to see kind of your building health at the big picture, how many total faults you have, how many have been corrected, and those loops closed on issuing the work orders and so forth. This is just one example from one of our partners of how they keep track of all their faults in a dashboard. This is becoming a lot more common, and it's really helpful when you have multiple buildings also with FDD in place. Next slide. All right, so here we are at our example slide. Again, it's just a subset of the over 40 tools out there. We're going to talk next in the next section about energy savings and costs, but this is a summary of that based on our research. Really what FDD does is allow you to detect problems that maybe you wouldn't have found before, but at least you're finding them with less analysis time and you're verifying that they're being fixed. Many of the organizations that we work with, and I think one of the folks are on this call right now at University of Iowa, are moving from reactive to proactive maintenance. So it really helps you make sure you're finding things and fixing things before you get those maintenance requests. Next slide. Okay, now we are to automated system optimization. So this one is a little different because there is a feedback loop. So the other ones, EIS and FDD, there's those diagnostics and you have to go and then do something and then you check again and see if the diagnostics are still flat. With ASO, it's actually a supervisory control software that's an overlay to your BAS that is designed to use predictive modeling to optimize system performance. So right now, the technology is really generally focused on chilled water plant and air handler optimization, but that is expanding and there's research being done by the lab in different ways to auto-correct controls. So this is all controls focused. You can't have automated system optimization where your dampers are automatically fixed if they're broken. This is all like set point optimization kind of stuff. So the automated system optimization writes back set points, optimizes in ways that building automation systems typically don't. Next slide, please. Here's an example. So we have the same data input or real-time BAS data. We have information about the system and how it's intended to be controlled. In this fault detection piece here, let's say our actual discharge air temperature at our supply fan is going up and down. That's sort of like an indicator of a fault. So an FDD, which is often paired with ASO, would find that fault and say, your system's unstable, something's going on there. So that's the first layer of finding those problems. Your BAS set point may be telling it in this light blue line what to do, but it's not following that. Then there's this other layer of the ASO runs this predictive model and optimizes in real time for all sorts of things, including weather. Some of them are starting to get into things like time of use pricing and things like that too. So they're optimizing for cost. So this green line is an example of, well, the blue line is the original BAS set point, how the discharge air temperature is being reset over time as load changes. And the green is a more optimized set point based on all these different parameters that are modeled. And then in the end, you're going to look at what your kW per ton for the plant is. And it's going to, through this process, optimize that energy use at your chilled water plant. Okay, so this is one of the examples here. Next slide shows a screenshot of one of the vendors. And this shows what an operator would see. So it shows how the BAS set points differ from the ASO generated set points. You know, understandably, operators can be concerned that their set points are being overridden, and operators can always override the ASO optimization if they're not comfortable with it, let's say on a super hot day. But this system should predict, because it knows weather forecasts and things like that, what to do to meet optimally. And like I said, LBNL is doing additional research on auto-correction of other faults beyond the central plant and air handler optimization. And there's a limit to that, but there is more that can be done there and really helping close the loop without as much user intervention, human in the loop. All right, so next slide, we have some examples here for vendors. And the real benefit here is that you're optimizing in real time. It's generally focused on systems that are larger that are either variable flow already, or you're willing to do a retrofit to variable flow, air and water, water side. So it really requires that level of kind of tuning and optimization ability. In terms of costs and savings, we are currently doing some studies on that in terms of field validations, and we don't have enough data to say this is really the costs and savings of these yet. You know, early indications basically say what engineers usually say: it's dependent on your base system design, which is true. So we're going to be trying to clarify the base system designs that are most applicable to ASO. Next slide, please. All right, so we're here to the summary. This is just to kind of see where we've been so far. We've gone through monthly all the way to real-time optimization, and you know, thinking about what your needs are is an important piece. So in making the business case, next slide, please. We are excited to share with you our findings from the Smart Energy Analytics campaign. This just came out last fall. Well, it's already last fall, but it's the most recent data available on savings and costs, benefits, cost effectiveness of EMIS. We were able to get enough data to provide savings and costs on EIS and FDD. We've also have an EMIS application showcase, which shines light on many of our award-winning campaign participants and their best practices. So this is a really great document to get started and get the flavor of what your peers are doing. And then we also have an infographic that gives you just a snapshot. It's good for management and people who don't have time to read the whole report. So that's there on the right. And all these are available at smart-energy-analytics.org. Next slide, please. Just zooming in here on the infographic for a second to say something about the campaign. This presentation is not about the campaign, but the data came from over 104 mostly portfolio level organizations that entered the campaign to get technical assistance, be a part of an awards and recognition program, and also provide us data. So we had almost 570 million square feet of lots of different building types in the commercial space. Mostly larger buildings, some below, actually a good portion also below 50,000 square feet if they're a part of a portfolio. And these are annual savings and costs. I'm going to dive a little bit deeper into those. And we found an investment payback of 2 years. Next slide, please. Also on the previous slide, I just wanted to mention, if you can flip back for a second, that we covered 40 different EMIS vendors. So of the 100 plus out there, we do represent quite a wide range of different vendors, and we obviously don't promote any particular vendor. We mostly promote using these tools because they did save energy. Okay, next slide, thank you. Our top measures that we tracked from those that implemented EMIS, they said, these are the measures that EMIS helped me implement. These are not surprising if you know about existing building commissioning. It's the same set of measures of optimizing schedules, set points, simultaneous heating and cooling, economizers, reset schedules, reducing overventilation, tuning loops, and so forth. Every time we look at what measures are implemented, this list is pretty much the same. And even across all market sectors, except higher ed and office had a more focus on occupant engagement. So that was another thing that they did with their EMIS, is that they shared some of that data with occupants to try to change practices. All right, next slide. We have energy savings coming out of the campaign. So we had almost 90 million square feet of EIS and of FDD. We had much more square footage in the campaign, but not everybody was able to provide or are far enough along in their process to give us enough data where we could calculate savings. So for those folks that were far enough along, we have a median savings EIS of 3% and FDD at 3 times that of 9%. The top quartile savings, so we would say those are kind of the best practice, really have used these tools and gotten great use out of them, are much higher in the 10 to 20% range and higher for FDD. So we have higher savings for FDD, but we'll also see here in a couple slides that the costs are higher too. So we're going to compare those in a second. Next slide, please. So energy savings since EMIS installation. Let me orient you to these graphs here. We have the 0 along the x-axis is our baseline year. So the year prior to installing EIS or FDD here on the right. Each year after, we have the savings relative to that baseline year. And the red is the median savings over time. So you'll see that these red lines, especially for FDD, goes up over time. We chose year 2 savings to report out. It makes sense for making sure we had a full year of post-implementation data and people are actually like have implemented their system and had it integrated into their management processes by then. All these savings, I should say, are not exclusively attributable to EMIS. These are energy savings from those that have installed EMIS. You know, so we are not saying it's only the EMIS, and in fact, in out years, we see a lot higher savings, and a lot of those cases we know anecdotally are because they were able to identify retrofits through having a much better access to their data and understanding what's going on with their systems. So it's kind of like helping in other ways than just operational. It's helping with master planning and retrofits. All right, next slide, please. On the cost side, I'm just going to summarize costs here on the per square foot column. We have EIS at 1 cent a square foot on the base software and installation. So that one-time cost to get things up and running, and then the annual software as a service cost is also another 1 cent per square foot. We did have a lot of large portfolios, so we also put a per building and per point cost because you know, the per square foot cost goes down quite a bit when you're talking about large portfolios. On FDD, you'll see the costs are higher, 5 cent, 2 cent. And then next slide, if we look at how these all come together in terms of cost effectiveness, we had enough data to do this calculation for 24 organizations. And miraculously enough, we came out with 2 years for both. So EIS saves less, costs less. FDD saves more, costs more, but it's about 2 years. And the outliers on the FDD really were cases in which the folks installing them hadn't really gotten them integrated into the organization yet. So the cost had showed up, but the savings hadn't showed up as much. Those were more pilot cases. All right, so costs and savings are looking good, 2-year payback. This is the kind of information that if you have additional questions on, if you want us to slice and dice to, you know, we did some more analysis on market sector. We're going to come out with a journal paper hopefully this year about that. So there's additional ways we're slicing and dicing this data to get building level costs. These are portfolio level costs and savings. All right, in the interest of time, we're going to keep moving on. Key points in the EMIS journey, hot off the presses, as of like yesterday, is a new update on the EMIS Primer. This is a kind of a guide on what are EMIS. A lot of things we talked about are in this guide, but then also the process. It really focuses on the planning, the implementation, and the ongoing use. So within this guide, we talk about how to define what activities you want to do with your EMIS to meet your goals, who will use it, how will it be used in order to set your scope. There's no one scope, and we have lots of resources available to, let's say, write an RFP, for instance. On the implementation side, we have system information from the vendor, lists of commissioning and configuration issues, and training and so forth. So this is a good guide to read if you haven't ever implemented EMIS before and you want to get a lay of the land and getting started. All right, next slide. I'm going to talk about just a couple of best practices to round out this presentation that we've seen a lot from our campaign participants and just over the years working with owners. One of the key things is selecting an EMIS with features that you want to use. So don't select an FDD because it's what your neighbor's doing. Select an FDD because you really want to see what faults are going to show up for your systems. You want to close the loop on those faults and make it a part of what your business practices are. Beginning with features that only require existing data. You know, nobody wants to add a whole new slate of sensors and then get all those up and running and then implement their EMIS. Most of these EMIS can really just use like your existing BAS or your existing meters. You may have to add an interval meter here or there. Scaling up within a portfolio. These are kind of just generally important in energy efficiency. You might want to begin with a pilot to demonstrate effectiveness and then expand. We saw a lot of folks doing that. And then standardizing your process. Data standardization is something that the EMIS vendors will help you with, naming conventions and mapping points to their system. Those are all key issues in making sure that the EMIS is working well for you. Next slide. And then this is just a summary to say, you know, if you allocate time to regularly look at this stuff and integrate it into your practices, you're going to get value out of it. We've seen that time and time again. It didn't matter as much, you know, what the initial baseline energy use was or how big the building was or so forth. What mattered was like using the tool and you know, closing those loops, taking action, and using the EMIS to quantify savings and share those savings with leadership. Next slide, please. Here's a quick overview of the different types of service providers that are available to help you. The EMIS installation and commissioning is, you always get help with that. So the vendor is going to configure their EMIS for you, make sure those diagnostic rules are set and that kind of thing. The ongoing EMIS data review, it tends to be an option. You may have that as an option with your vendor or with a monitoring-based commissioning service provider, where they'll help you work through sort of like daily or weekly or monthly, prioritizing the findings, like digging into the VAS data to help you. Some vendors have this a part of their package and others have it as kind of an add-on, or you have an engineer that helps you with that separately. And then if you want sort of an extension of your building operations staff, you can also hire the MBCX service provider to really, you know, to come on site to be a part of that team that helps implement the findings. Next slide, please. All right, so here are our favorite resources. We have our new primer, we have the final report, the application showcase. I didn't mention the success stories so much, but we have 24 success stories written from the campaign. So you can find one that's similar to what you're interested in. We do also in those success stories list which tools they used and how much saving they got. And then the procurement spec is a great way to start with everything in the kitchen sink and pare it down to what you really want. So we have this procurement spec and then example RFPs, anonymized RFPs from about 12 participants from the campaign that might be helpful for you as starting points. So here's all these links. You'll get these slides later. And feel free to reach out to us if you have questions on you know, how to use these resources or want to get connected to, you know, other folks they're doing the same kind of thing within Better Buildings. All right, I'm going to leave it on, actually, next slide, please. And we're going to leave it on this slide for Q&A. There's ways to get involved. You can join Better Buildings Alliance. You can join the EMIS tech team. So we send out webinar announcements and other information on new resources to this EMIS tech team list that's a part of Better Buildings. So you can just email to this if you are not on this list or if you found out about this webinar in a different way, and we'll make sure you're on that list. All right, we have 10 minutes for Q&A. I will turn it over to Elliot to ask some questions, and make sure you get your questions in through the chat. Elliot?
There we go. Unmuting, I should have learned that by now. Yeah, great work, Hannah, and thanks to everyone who's submitted questions so far. Keep them coming. So the first one, I have many vendors approach me about their EMIS and having a hard time comparing them. Any resources or suggestions?
Yes, this is a really common problem, a common question. And the way we like to approach it, because we're not going to tell you which tool to use, is to first determine the capabilities you need, like we talked about. So you could start out with that RFP, you could pare it down, and then issue the RFP and invite responses from the vendors you've heard good things about, or from some of the vendors that your friends are using, and then see how the proposal meets your requirements. And then at the interview stage, one thing I would recommend is have vendors show you how they meet your key requirements. Sometimes it's really hard to get through kind of the marketing materials and piece out, so what do they really do versus not? So ask them the questions about, like, show me how you do your baseline modeling and what I would need to do that within your tool. And don't have them just do screenshots, have them kind of show you how to do that in a demo. So really putting out what you want and then having people respond to it can often get you the folks that are most eager for your business and wanting to prove that they can meet your requirements.
All right, great. Next question. How do I get my utility data into an EMIS?
So for the monthly data analytics, some of those vendors have ways to help support that process of getting the data from your utility into the software. Some actually use another tool called Urginet, who really specializes in that as well, to connect and get that data seamlessly into the tool. So working with the monthly data analytics folks, they will help you get that process in place and make sure it's accurate.
Okay, next question. What kind of organizations use EIS versus FDD versus ASL?
Yeah, good question. It really depends on who you want to be who is your champion. So let's say your champion for this is your energy manager, and their biggest headache is they have to track all these meters and they don't know if the meters are accurate and they don't have a good way to benchmark. It's just like that first slide, it's kind of a mess. So if your champion is your energy manager, chances are they're going to want an EIS because it's going to make their job a lot easier. If your champion is a facilities engineer, you may want to start with FDD, even though it's a more complex installation. It may be the thing that you're going to use, and they want to be able to optimize their system and know what faults are happening and so forth. I'd say ASO is for folks that have a little bit more complex systems generally that have larger central plants so far. We'll see how that evolves.
Okay, thanks, Hannah. Next one here. I hope I'm interpreting this right. So can you comment on the pros and cons of pursuing EMIS/FDD?
So yeah, so EMIS.
Sorry, Hannah, to cut you off. I just see that whoever submitted that, I think, hit send too soon. So let me see if I can pull up the full question here. Can you comment on the pros and cons? Hang on a second. I need to make this window a bit bigger. Can you comment on the pros and cons of pursuing EMIS FDD ASO by building independently with different vendors, or taking an integrated approach by organizing all data, then running analytics globally?
Mm-hmm. Yeah, so there is a question of like, should I consolidate to a single vendor if I have a portfolio? And the answer usually is yes, just because you're going to get to really know that tool. I guess if you had different operations teams in each building, you could choose different tools. But if you have any central coordination, it's good to have a user group that can talk about what's going on and use the same interface and so forth. And any central look will be able to look at those analytics globally and compare across sites and so forth and have dashboards. So I think, some people start out with a pilot and maybe a few different vendors in pilots in different buildings, but then decide, okay, this is what we're going to consolidate on and get the most bang for our buck across a portfolio.
Great, thank you. Next question, this is from an EMIS vendor. I'm an EMIS vendor, can I join Better Buildings?
Yeah, so we mentioned Better Buildings is generally for owners, operators, energy managers, that type. So those are the types that can join as Better Buildings partners. However, we take anybody on our EMIS tech team list, and we do have a lot of vendors on our EMIS tech team list that want to keep in touch with us about the research and what the latest is on what we're seeing in the industry. So sign up for that EMIS at lbl.gov, whether you're a service provider, a vendor, or anybody, and we'll make sure you're in the loop on that kind of thing. Being a part of Better Buildings as a partner means you're connected up with a whole network of support. So joining Better Buildings is a great thing. It gets you contact with all the national labs on a variety of things. So as an owner, operator, manager, that's the direction to go.
Great, great. Next one, this is a good one. So we don't have a building automation system. Can we still do FDD?
Yeah, I didn't talk about that too much. We had been talking about BAS being the main data stream to FDD. There's also FDD for what's called, generally called an advanced rooftop unit, where they have some FDD algorithms built into the controllers in the advanced RTUs. So that's another way, if you don't have a BAS, that you can still do FDD. There's some other ways to do FDD, like with IoT sensors. So you're kind of building up a simple BAS with sensors, but it's hard to do a full FDD installation the way that these tools are generally set up, with hundreds of different rules, looking at all sorts of things without a comprehensive set of data. I mean, your faults are only going to be as good as the set of data that you have to base them on.
Okay, we maybe just have time for one more here. This, I think, is relating to the slide where you talked about the level of service provider support. So the question is, how often do organizations manage their EMIS with in-house staff?
Yeah, so in-house versus third party. In our campaign, at least, it was about half and half. So generally, the larger organizations that had a little bit more capacity to hire in-house staff to help and to be like an expert on, let's say, FDD, would hire that. But even ones that had a lot of in-house staff, but just didn't have enough money to hire a new staff person or to get that training to be an expert, would hire a third party. and they would kind of become a trusted advisor to helping them analyze what's coming out of these tools and prioritize findings. And so it really could go either way. It kind of just depends on your interest level of being the one in charge of all the details around the tool, or if you want someone who's that's kind of what their business is.
Okay, with that we've hit the hour, so I guess you should probably wrap up now.
Okay, thank you, Elliot. Thanks for the questions, and please feel free to reach out to us with additional questions if we didn't get to yours. I appreciate your time, and have a great day.